Hello friends, I am Mohammad Azhar Iqbal Nawalgund, Assistant Professor, Department of Physics, Government First Grade College, Mundargi. Today we are going to solve problems on Thevenin's and Norton's theorem. In the previous class we have studied the Thevenin's theorem statement and its proof, Norton's theorem statement and its proof. The outcome of this session is you are going to solve the problems on Thevenin's theorem and problems on Norton's theorem. In the previous class, we have studied the proof of Thevenin's statement, measuring Thevenin's voltage by using the formula VTH or VOC is equal to ER2 divided by small r plus R1 plus R2. After that, you have measured the Thevenin's equivalent resistance by using the formula RTH is equal to R2 into bracket small r plus R1 divided by small r plus R1 plus R2. After that, you have replaced the entire network with a single voltage source in series with a single resistance. After that, you have calculated the load current by using the formula IL is equal to VTH divided by RTH plus RL. Then you have studied the proof of Norton's theorem or Norton's statement. Here you have measured the short circuit current by using the formula I is equal to E divided by R plus R1. After that, you have measured the equivalent Norton's resistance RN by using the formula 1 by Rn is equal to small r plus R1 plus R2 divided by R2 into bracket small r plus R1. After that, you have replaced the entire network with a single current source in parallel with the single resistance. After that, you have calculated voltage across A and B by using the formula VAB is equal to I divided by 1 by RL plus 1 by RL. Problem 1. With reference to network shown below, by applying Thevenin's theorem, find the following. First one, the equivalent EMF of the network when viewed from the terminals A and B. Second one, the equivalent resistance of the network when looked into from the terminals A and B. Third one, current in the load resistance RL of 15 ohm. The circuit is as shown in the figure. A 24 volt battery with the internal resistance of 1 ohm, a 3 ohm resistance, 12 ohm resistance and the two terminals A and B and a load resistance RL of 15 ohm. Now remove the load resistance and measure the Thevenin's voltage across the terminals A and B. After that, replace the EMF with its internal resistance R and measure the resistance across the terminals A and B. Step 1. Current drawn from the cell, that is equal to 24 divided by 1 plus 3 plus 12. That is equal to 24 divided by 16. That is equal to 3 by 2 amperes. Step 2. EMF across A and B is equal to potential difference across 12 ohm resistance. That is equal to 3 by 2 into 12. That is equal to 18 volts. Therefore, VTH is equal to 18 volts. Step 3. Effective resistance between A and B. RTH is equal to 4 into 12 divided by 4 plus 2. That is equal to 48 divided by 16. That is equal to 3 ohms. Step 4. Draw the equivalent circuit and calculate the load resistance. Now you have drawn the equivalent circuit with the 18 volt Thevenin's voltage source and a 3 ohm Thevenin's resistance which are connected in series and a load resistance of 15 ohm. IL is equal to VTH divided by RTH plus RL. That is equal to 18 divided by 3 plus 15. That is equal to 18 by 18. That is equal to 1 ampere. Problem 2. For the circuit shown below, Determine the current through RL when RL takes the values of 5 ohm and 10 ohm. The circuit is a 10 volt power supply without any internal resistance, 2 ohm resistance, 4 ohm resistance, 5 ohm resistance, two terminals A and B and a load resistance across it. Step 1. Remove the load resistance and measure the Thevenin's voltage across the terminals A and B. Current through 4 ohm resistance. First we have to calculate the current through 4 ohm resistance. That is equal to 10 divided by 2 plus 4. That is equal to 10 by 6. That is equal to 5 by 3 amperes. Step 2. Thevenin's voltage VTH is equal to potential difference across 4 ohm resistance. Therefore, VTH is equal to 5 by 3 into 4. That is equal to 20 by 3 amperes. Step 3. Effective resistance between A and B. RTH is equal to 2 into 4 divided by 2 plus 4 plus of 5. That is equal to 8 by 6 plus 5. That is equal to 4 by 3 plus 5. That is equal to 19 by 3 ohms. Step 4. Draw the equivalent circuit and calculate the load current. Now you have replaced the EMF with the Thevenin's voltage source 20 by 3 volts and a Thevenin's resistance 19 by 3 ohm resistance connected in series and a load resistance. By using the formula, IL is equal to VTH divided by RTH plus RL. Case 1. When RL is equal to 5 ohm, that is equal to 20 by 3 whole divided by 19 by 3 plus 5. That is equal to 20 by 3 whole divided by 34 by 3. That is equal to 20 by 3 into 3 by 34. That is equal to 10 by 17 amperes. Case 2. When RL is equal to 10 ohm, that is equal to 20 divided by 3 whole divided by 19 by 3 plus 10. This is equal to 20 by 3 whole divided by 49 by 3. That is equal to 20 by 3 into 3 by 49. That is equal to 20 by 49 amperes. Problem 3. Use Thevenin's theorem to find the current in a resistance load connected between the terminals A and B of the network shown below if the load is 2 ohm and 1 ohm. The circuit is like this: 8 ohm power supply or EMF without any internal resistance, a 2 ohm resistance, 4 ohm resistance, 2 ohm resistance, 2 ohm resistance, and the two terminals A and B and a load resistance RL. Now, step 1. First you have to remove the load resistance and measure the Thevenin's equivalent voltage across the terminals A and B. In this circuit there are two meshes. In the first mesh the current I1 is flowing and in the second mesh current I2 is flowing. Now step 2. Thevenin's voltage VTH is equal to potential difference across 2 ohm resistance. By applying Kirchhoff's voltage law to the first mesh, minus of 2I1 minus of 4 into bracket I1 minus I2 bracket complete plus 8 is equal to 0. Minus of 2I1 minus of 4I1 plus 4I2 is equal to minus 8. Minus of 6I1 plus 4I2 is equal to minus 8, or 3I1 minus of 2I2 is equal to 4. Call this as equation number 2. Now applying the Kirchhoff's voltage law to the second mesh, minus of 4I2 plus of 4 into bracket I1 minus I2 is equal to 0, or 4I1 minus of 8I2 is equal to 0, or I1 minus 2I2 is equal to 0. Call this as equation number 2. From equation 1 and 2, 3I1 minus 2I2 is equal to 4, I1 minus 2I2 is equal to 0. That is 2I2 get cancels, 2I1 is equal to 4, I1 is equal to 4. From equation 1, 3 into 2 minus of 2I2 is equal to 4, 6 minus of 2I2 is equal to 4, or I2 is equal to 1 ampere. Therefore, VTH is equal to I2 into 2, that is equal to 1 into 2 is equal to 2 volts. Now step 3, effective resistance between C and D. First, remove the EMF and measure the Thevenin's equivalent resistance between the terminals A and B. For that, first you have to measure the equivalent resistance between C and D, and after that you have to measure the equivalent resistance between E and F. First, the effective resistance between C and D. These two resistances are connected in parallel. 4 into 2 divided by 4 plus 2, that is equal to 8 divided by 6 is equal to 4 by 3. Effective resistance between E and F. This way 4 by 3. These two resistances are replaced with the 4 by 3 equivalent resistance. That is equal to 4 by 3 plus 2 into 2 divided by 4 by 3 plus 2 plus 2. That is equal to 10 by 3 into 2 divided by 10 by 3 plus 2. That is equal to 20 by 3 divided by 16 by 3. That is equal to 20 by 3 into 3 by 16. That is equal to 5 by 4 amperes. 5 by 4 ohms. Therefore, effective resistance between A and B is equal to RTH is equal to 5 by 4 ohms. Step 4. Equivalent. So now draw the equivalent circuit diagram with 2 volt battery or equivalent voltage and a Thevenin's resistance of 5 by 4 ohm and a load resistance. Step 5. Now calculate IL using the formula IL is equal to VTH divided by RTH plus RL. Case 1, when RL is equal to 2 ohm, that is equal to 2 divided by 5 by 4 plus 2. That is equal to 2 divided by 13 by 4. That is equal to 8 by 13 amperes. Case 2, when RL is equal to 1 ohm, that is equal to 2 divided by 5 by 4 plus 1 is equal to 2 divided by 9 by 4. That is equal to 8 by 9 amperes. Problem 4. Find the voltage across the points A and B in the network shown below by using Norton's theorem. 50 volt battery, 40 ohm resistance, 50 ohm resistance, 20 ohm resistance, 100 volt battery, and the two terminals A and B, and a load resistance of 10 ohm. Now remove the load resistance of 10 ohm and measure the current across the terminals A and B by putting the short circuit. Current due to 50 volt battery from A to B is equal to 50 by 50, that is equal to 1 amperes. Current due to 100 volt battery from B to A, that is equal to 100 divided by 20, that is equal to 5 amperes. Therefore, short circuit current ISC is equal to downward current minus upward current. That is equal to 1 minus 5, that is equal to minus 4. Negative sign indicates that current flows from B to A. Step 3 and 4. Remove the EMFs and measure the Norton's equivalent resistance. Rn is equal to 50 into 20 divided by 50 plus 20. That is equal to 1000 divided by 70. That is equal to 14.2 ohms. Step 5. Draw the equivalent circuit and calculate the voltage across A and B. Now you have replaced the EMF with a current source and a resistance, equivalent resistance connected in parallel. Then the two terminals A and B and a load resistance RL. VAB is equal to ISC divided by 1 by Rn plus 1 by RL. This is equal to minus 4 divided by 7 by 100 plus 1 by 10. That is equal to minus of 4 divided by 17 by 100. That is equal to minus 4 into 100 divided by 17. That is equal to minus 400 divided by 17. That is equal to minus 23.5 volts. Negative sign indicates that B is at higher potential than A. Problem 5. Using Norton's current source equivalent circuit of the network shown below, find the current that would flow through the resistor R2 when it takes the values of 12 ohm, 24 ohm, 36 ohm respectively. The circuit is 120 volt battery, a 40 ohm resistance, and the terminal A and B, and a load resistance R2, 60 ohm resistance, and another battery of 180 volt. Solution. Step 1 and 2. Remove the load resistance and put a short circuit between the two terminals A and B. Current due to 120 volt battery from A to B. That is equal to 120 divided by 40. That is equal to 3 amperes. Current due to 180 volt. That is equal to 180 divided by 60 is equal to 3 amperes. Hence, ISC is equal to 3 plus 3. That is equal to 6 amperes. Step 3 and 4. Effective resistance between A and B. Remove the EMFs with their or replace the EMF with the internal resistance. In the given circuit, there is no internal resistance, so we have not connected any internal resistance here. Therefore, Rn is equal to 40 into 60 divided by 40 plus 60. That is equal to 2400 divided by 100. That is equal to 24 ohms. Step 5. Draw the equivalent circuit and calculate the load currents. The equivalent circuit is like this: a 6 ampere current source and a 24 ohm resistance connected in parallel and a load resistance RL. Using the formula, VAB is equal to ISC divided by 1 by Rn plus 1 by RL. Case 1, when RL is equal to 12 ohm. VAB is equal to 6 divided by 1 by 24 plus 1 by 12. That is equal to 6 divided by 3 by 24. That is equal to 48 volts. Case 2, when R2 is equal to 24 ohms. VAB is equal to 6 divided by 1 by 24 plus 1 by 24. That is equal to 6 divided by 2 by 24. That is equal to 72 volts. Case 3, when R2 is equal to 36 ohms. VAB is equal to 6 divided by 1 by 24 plus 1 by 36. That is equal to 6 divided by 5 by 72. That is equal to 86.4 volts. On the basis of this, we have some objective type questions. Question number 1. Find the Thevenin's resistance across the terminals A and B for the following circuit. The options are 4.34 ohms, option B 3.67 ohms, option C 3.43 ohms, option D 2.43 ohms. The correct answer is 3.67. Question number 2. Find the Thevenin's voltage across the terminal A and B for the following circuit. The options are 5.54 volts, option B 3.33 volts, option C 6.67 volts, option D 3.67 volts. The correct answer is 6.67 volts. Question number 3. Calculate the current across the 4 ohm resistance in the following circuit. The circuit is here. The options are A 0.86 amperes, option B 1.23 amperes, option C 2.22 amperes, option D 0.67 amperes. The correct answer is 0.86 amperes. Question number 4. Find the Norton's resistance across the terminal A and B for the following circuit. The options are 10 ohm, 11 ohm, 12 ohm, 13 ohm. The correct answer is 12 ohm. Question number 5. Find the short circuit current across the terminal A and B for the following circuit. The options are A 0.72 amperes, option B 0.32 amperes, option C 0.83 amperes, option D 0.67 amperes. The correct answer is 0.72 amperes. Question number 6. Find the current in the 5 ohm resistance using the Norton's theorem. The circuit is here. The options are 1 ampere, option B 1.5 ampere, option C 0.25 ampere, option D 0.5 amperes. The correct answer is 0.5 amperes. The references for this section is Fundamental of Physics by Halliday, Resnick, Walker, 2002 edition, Principles of Electronics by V.K. Mehta, and Rohit. Thank you.